Okay, I'm sharing my screen and we'll get started here. It says to use the limit definition of the derivative to compute f prime of x for f of x equals 2 minus 3x minus 4x squared. You're not allowed to use the power rule. Whenever it says limit definition or definition of the derivative, you're going to be using this notation. Limit as h goes to 0, f of x plus h minus f of x all over h. And this is the derivative.
Okay.
Okay, so you start with that. And then we're going to come back to this on the left, but you have to be able to compute f of x plus h. You have to be able to, you have to say, okay, I got to substitute that in wherever I see an x. Okay, and then you do have to simplify this. So that's probably the the hardest part is reducing this thing. So just need a little more room here, but it's distributive property minus 3x minus 3h minus 4, and then x plus h squared is really x plus h times x plus h, and so you get x squared. You get an xh and an xh when you do the outer and the inner, so that's 2xh's plus h squared. The more you can simplify and do as you go, the less writing you have to do. These are very long problems. That's why you were given the whole page for this. So you have to be able to calculate that. And then it's just you're looking for three pieces. So you have this f of x plus h, that's this now. And then you have f of x, which came from the original. And then h is just h. It's just whatever, it's there. So we're going to substitute in, but to do this correctly, to do this formally, you have to get more space so you can write this out. Okay, you have to write the limit. There we go. Okay. You have to write the limit as h goes to 0. And then you have to grab, all this stuff here that it's easy for me because I just copy and paste here, but you need to grab all that. Subtract f of x. So you want to do that in parentheses. That's 2 minus 3x minus 4x squared, like this, all over h.
Okay.
And from here, again, a lot more writing, but in the numerator, just grab this again. In the numerator, this time I'm going to distribute that negative to everything. So it's minus 2 plus 3x plus 4x squared. So you just change the sign. And then now you can cancel like terms. So 2 cancels with minus 2, minus 3x cancels with 3x, and minus 4x squared cancels with 4x squared. And so you...
isn't it like you shouldn't have anything without, you should only have like h's in the after elimination. Okay, yeah.
Yes, let's say it that way. That's more positive. Only h terms left over. That works for polynomials. It does not work for other things.
Okay.
And there's a couple other types of problems they can give you, but it would appear it's a polynomial. You could probably look at your old lesson notes if you wanted to see the other types as well. So you come down here, h goes to 0, minus 8xh minus 4h squared all over h. And then you have to divide both of these by h. So it becomes minus 8x minus 4h. And it's up to you. I mean, I don't know. I think this is too much to like show this, but it's up to you if you think you need to do that. But when you get it, and I'll put this in red here. When h is gone from the denominator, you just evaluate for h now. Because the issue is, and I didn't say this, but the issue is if you go back to the original, when you put 0 in for h, you're dividing by 0. When you put 0 in for h, you're dividing by 0, and so on. But finally you get to the place where you're like, all right, I'm not dividing by 0. So you can literally go equals, and this is now f prime of x equals minus 8 times x minus 4 times 0, which is minus 8x. So it should be a function of x, your derivative.
Okay. I remember this.
Yeah.
From...
and you learn it and then you forget it.
Yeah.
You will only
it's just like such a long way to do it when you could just do the derivative so easily, you know?
Yeah. Yes. You just use the power rules.
Yeah.
Which are truly what they are, though, is they're generalizations of the formal way of doing it. They're just noticing
Right.
patterns. And
Right.
you know, you think what you want of that, but like I said, there's ones with roots, there's ones with rationals, and I'm sure we did that. If you go back and look, you can probably find a few. I wouldn't do them unless you're, you know, got tons of extra time. It's probably going to be a polynomial like this.
Okay. Yeah, usually like his sample exams are his old ones, so they're pretty much the same.
Yeah. All right. Oh, that reminds me to tell you. So I don't know how much. So if you know what classes you're going to take next semester, you may find it's good to go to their, you know, if you got a friend that's in that class and start downloading materials, you know, preemptively.
Yeah.
Sometimes they pull them, of course, but you know, boy, it's really nice to see what, you know, next semester's biology exams look like. So you
Right.
get a heads up on it. All right. That's it. I mean, unless you want one like it, we can move on to 7A.
Maybe I should do one just like myself through it.
Great. So we'll have you do 7A, but we'll have you doing it using the definition of the derivative.
Okay.
Because it's pretty much the same type. So I'd like to start working it out unless you
Oh no, go ahead. I won't look.
Yeah. Okay. Sounds good here.
Okay. Yeah, I got the same thing.
Okay. Fantastic. All right. That's good. Maybe run through that process one more time for your exam. So let's just briefly review a few of the derivative rules. So d dx of x to the n is n times x to the n minus 1. And an example would be like d dx of x cubed. That becomes 3x squared. This is the power rule.
Mhm.
Another one, it's really a derivative of this. It's c times x. The derivative of a constant times a variable is always the constant. So the example here is d dx of minus 7x is minus 7.
Mhm.
Okay, and then d dx of a constant is 0. So the derivative of like pi is 0. This is
Right.
probably enough to get us through the next few problems to be able to do them here. So let me make up another problem like 7a alternative. Let's say g of x equals 5x squared minus 2x minus 1. Okay, so the derivative here is power rule. In the first one, take this 2 and multiply by the 5, you get 10x. You're always
Minus
subtracting.
2.
Yeah, you're subtracting the exponent by 1 each time.
Mhm.
They might want to see that at this point in the course. For the next one, though, it is just minus 2
Mhm.
and then minus 0. I remember some of the students in your class have never taken calculus before, so they're going to really like not, it's like you know these things, but you're not supposed to really know them, and there's a little bit of expectation, a little more work to be shown here,
Mhm.
like that. So something like that.
Okay.
Any questions on that?
No, I got
Okay.
it.
Okay, so a couple of reminders on exponents. So if I have 1 over x cubed, this is really x to the minus 3. And the rule is 1 over x to the n equals x to the minus n. Okay, so you basically bring that exponent up. And then roots, remind you of this. So let's say it's the square root of x. This is really x to the 1/2 power. And the reason is there's really a 2 on the outside and a 1 there. And I like to remember this example to help me, not forget. But more generally, x to the m over n is the nth root of x to the m. And I'm bringing that up because you might get a problem where it tells you that it's the the 4th root of x cubed, and you need to write it as x to the 3 over 4 power.
Mhm.
Be able to do that.
Okay.
So you gotta have some sort of a reference. That'll come up in well, I gave that one away. Okay, let's look at 7b now. You have enough information to do a problem like 7b.
Okay.
The notation here is correct. It's actually good notation to do it this way, but if you want to think of your original function, you're like y. Your y is the t squared plus 1 over t squared. And this is what you might want to rewrite using those exponent rules.
Okay.
So it'd be like t squared plus t to the minus 2 power. And then you take a derivative.
Okay. So 2t.
So you bring that down, that minus 2 down.
2t. Yeah.
And then you subtract 1. So it's 2t minus 2t to the minus 3 power. And then you might want to go a little bit further. Since you're evaluating it, when you're evaluating, you do want to try and simplify. It does help a little bit. So this becomes 2t minus 2 over t cubed. And that's just the reverse, or not the reverse, the flip going backwards of this rule right here with your exponents. Okay. So, but like, okay, I'm sort of like not doing this. You're supposed to, I mean, this is correct. It's just, I wouldn't want you to get dinged for like points here. You would want to somehow say it's 2t minus 2 over t cubed, but then you have to evaluate it. This symbol means to evaluate when t equals 2. Have you seen that before?
Yeah. Yeah.
Okay. And then, so you can
just plug in the 2.
Yeah, you do need to make some sort of like, what's the right word? Like, you're trying to imply that like this work refers back to this and somehow this becomes this, some sort of connection. That's the right word. And so you just have to be comfortable doing that. So this is 4 minus 2/8, which is 1/4. So 4 is really 16/4 minus 1/4, which is 15/4.
Yeah, okay.
Let me know if you want one like that, or we can move on.
Yeah,
to
why not? Let's do
Okay.
another, maybe one more.
Okay. So we want dr of r cubed minus 1/r. And we're going to evaluate it at r equals 3.
Okay.
Will you give that a try, please? How are you doing on this one?
I got like 80/3.
Okay, let's work it out together. So the derivative is 3r squared. Actually, I'm sorry, I'm supposed to rewrite it first. Minus r to the minus 1. And so it becomes plus r to the minus 2 power, because those two negatives become that. So you could rewrite it as 3r squared plus 1/r squared.
Wait, why is it to the -2?
So you always subtract 1.
Oh, that's where I messed up.
So so in terms of your notation, let me, now that I've had why I'm off today. It's probably because I don't usually do lessons on Saturday. When you should keep using this notation until you take a derivative. So like you should like when you're rewriting it, you should keep it in the brackets and then use the power rule to get your answer. But it's -1 for that.
Got it. Okay.
So it's r to the minus 2.
1/3 squared. Okay.
And then you're evaluating at r equals 3. You want to give that a shot from here?
Yeah. Let me fix.
Actually, I may have made the numbers too large. Why don't we change this to 2?
Okay.
Because it does sort of add some unnecessary multiplications.
2 squared.
Do you have an answer for me?
49/4.
Yeah, that's correct.
Okay.
Yep. Great.
All right.
All right, here's another question. All right, it says compute the derivative of, and again, notice like it does not say to use the definition of the derivative. I mean, you have the added help with probably knowing that it's question 7 or topic 7, but don't try to do these with the definition of the derivative unless it tells you. So you definitely want to rewrite here, and we had mentioned that earlier. So this is a root. This becomes 3/4. So that root always goes to the bottom. The exponent always goes to the top. And then you could further rewrite it, bringing it up into the numerator, t to the minus 3/4 like this. We still have not taken a derivative. These are just rewrites. And
Okay.
you should expect that. So now derivative, v prime is fine. You could go dv dt. They're all the same. In this case, the variable on the bottom is the thing you're taking the derivative with respect to. And so it's power rule 2t plus 3/4, because you bring that minus 3/4 down. And then you have to subtract 1 from the exponent. So you're effectively going minus 4/4.
Mm-hmm.
And that gives you minus 7/4. And so since you're not evaluating it, it's fine like this. Most instructors accept this. They don't need you to simplify. Some instructors, they want you to use only positive roots. Any chance this is multiple choice as an answer?
No, he doesn't
Okay.
do multiple choice.
Okay. So that's it. So I had to give you one to try, unless you have some questions on this.
I don't think so.
Okay. Let's say p equals 5x to the 8th minus, let's go 1 over the cube root of x. Maybe try that one, please.
Okay. Sorry, so the bottom turns into x to the 1/3, right? On that square root.
Yes, like that.
And then from there, you do the derivative by bringing the x up.
No, I would bring it. You're still rewriting it. You're not yet taking a derivative.
Okay, so you just, okay, perfect.
Sorry, and there's a negative there.
Right. Wait, so if it was like a 2 on the top, it would just be 2x to the negative 1/3.
Yeah, and see, that's what I'm noticing is lacking in these examples, is they're not putting constants in some of these places where I'd probably put like a 6 up here. So let's do that, because it does give you just
Okay.
a little extra tiny thing to think about while you're working on these things that you should be able to handle.
All right. is it just 40x to the 7th plus 2x?
You have to subtract the exponent by 1.
Oh, I just left it. Okay.
Yeah.
-1
It's it's a fraction. You're gonna get it generally when you have a root in your original function, you get a root in your derivative.
Okay, so -4 thirds then on the
Yeah.
okay.
Do you want another one, or do you want us to move on to product rule and quotient rule?
Let's move on to product rule and yeah, it might be quotient rule. I don't know. It could be one or the other.
All right, let me snip that in. All right, compute d dx of x to x plus 5 times x squared minus 3 using the product rule. You could actually FOIL and then take a derivative, but they're telling you like to use the product rule. So let's review the product rule. My preference, Matthew's preference, is to look at it as u times v. Is that what you're using in class, using f and g, or does it matter to you?
I think we're using u and v.
Okay, and there's a reason for that. Like they should probably at some point tell you like, why is it you? Because we're doing substitutions later in the course. So it's just you gotta, and the order doesn't matter, but I like u v prime plus v u prime. There's a couple of different ways that you can do that, but essentially you take the derivative of one, keep the other one, take the derivative of the other, and you mesh them together. So you might even remember us doing this the following way. I actually had you write out the u and the v, and we take the derivative one at a time. So u prime is just 1 in this case, and v is x squared minus 3. V prime is 2x, and then you combine these sort of diagonally. So it's like v, that didn't work. We'll go with different colors. These end up combining that way. Okay, so let's see what I mean by that. You're always pairing the original with the derivative of the other. So uv prime is x plus 5, and then v prime is 2x. And the parentheses are nice because they hold kind of like and it makes it easier on this person to grade as well. They hold the thing in so you can see it. V u prime is the other one, and the order doesn't matter. A lot of students get hung up on that, like, can I put u prime first and then v? Yeah, it doesn't matter. Just make sure you're pairing them up. And then the question for you, because I don't know, is did your instructor want you to simplify this?
Let's see. Let's keep this on the notes really quick. First topic 2.6. Okay. There it is. We, yes, simplified it from there.
All right, so depending on the problem, but you will want to distribute in. So you're going to get you're going to combine like terms 2x squared plus 10x, and then plus x squared minus 3. Obviously, they could be a little more sophisticated.
Yeah,
go ahead.
For like the really long ones, that was like 2x to the 4th minus 3x plus 5, and then at times like a whole nother thing. We left it at like the without simplifying step kind of. Like I think just the simple ones he wants So 5 basically.
Yeah, and I think, I don't know. I mean, to me, it should say, like, I feel like there it should, and then simplify. And then I think there's an expectation to actually say, like, do not simplify for the ones that are really awful.
Yeah.
But okay, why don't I have you try one here? And again, kind of the same deal as the previous problem. Like this is the notation is totally correct here. It's just that we're kind of like everything until this arrow is like side work, and then your actual derivative line starts down here. So it's like just because you mentioned being really formal, and like there's nothing wrong with anything here. It's just that, like, if this were in a math paper, we would just go right from that first line to this one.
Right.
But we're not writing a math paper, so I don't know. Let me give you one to try here, please. Let's go dy of 2y minus 1, and then 4 plus y squared using product rule.
Okay, I got 6y squared minus 2y plus 8.
Okay, so yeah, let me work this out here. 2y minus 1 times 2y plus 2 times 4 plus y squared, 4y squared minus 2y plus 8 plus 2y squared, 6y squared minus 2y plus 8. Very good.
Okay.
Okay. Yeah, hopefully you get one of those. Probably won't, though. All right,
Yeah,
let's
he
look.
might switch it up and do quotient row.
Yeah, yeah. It's what I'm not seeing here, maybe it's in the next one. I'm not seeing any chain rule questions. So
It'll be on the next test.
okay. And that's good to know, because I won't make these like more complicated than they need to be. So the quotient rule is u over v prime. And I like it in words, but it's the bottom, which is v, times the derivative of the top, minus the top times the derivative of the bottom, u and v prime over the bottom squared. You gotta remember. Go ahead.
I was just gonna say, oh, he did put a quotient rule in there already.
This one's harder to remember. It's easy to get the order wrong, and
Yeah.
just take the time to remember it. I don't have a good strategy for it. Maybe there's a TikTok video on how to do this. I have no idea. But just like the previous problem, you do kind of come off to the side here and you're like, all right, it's t squared minus 3t plus 1. And then you find u prime. And it's just power rule again, 2t
Yeah.
minus 3. And then v is t plus 1. V prime is just 1. And then you just start meshing things together. So so in terms of your derivative, it's t plus 1, and then u prime is 2t minus 3. And again, I like to kind of keep everything in parentheses. U t squared minus 3t plus 1, and then v prime is 1 over v squared, so t plus 1 squared. Okay, but
Okay.
then we're not done. It says it actually says to evaluate it at 1. That's why we don't have to simplify. I would just evaluate it right now, and I would take the time to rewrite it and not try to simplify. I think you're pretty good at that from what I remember when I saw your
Yeah.
work, that you're not going to try and do too much in one step.
No, I like to see it usually,
And
so that I know where I made my mistake. I do make a mistake.
so we got, let's see here, order of operations, 1 minus 3 plus 1. I mean, I don't know, you can get too crazy, and you get eventually you got to actually evaluate this thing.
Okay.
And like what I'm noticing, your instructor like chose 1. You might not think much about it, but like -1 really adds a lot of complexity to this with signs.
Mm-hmm.
And same thing like here in this product rule, because this minus 3 is just, it's irrelevant. This is positive. Like he's really choosing nice examples that work out very cleanly. I don't know if your
Mm-hmm.
exams are like that, but that's something to consider as well.
Okay.
So let's try another one here. Let's try dp of p squared minus 4p plus 1 over p minus 2. And we want to evaluate that at p equals, let's see if that'll work out. Let's try, we'll just go 1 again. We don't need to get 2 to 2. But give that a try, please.
Okay. The derivative of p, would it just be 1?
Yes,
Okay. Wait, so then when is it? It's 0 if it's like derivative of 2. That would be
that's right. That's right.
okay.
So it, like I'm just using different letters, but dx of a constant is always 0. So whether it's x, p, y, whatever, if it's a constant, it's always 0.
Okay. Got it. I got 4.
Yeah, that's correct.
Okay.
And I just used Wolfram to evaluate that. Okay, I mean, not much more to it than that. But
Perfect.
you know, be aware there's so many variations. I couldn't
Yeah.
pretend to be like, yeah, it's for sure going to be this. All right, this
Right.
next one is definitely more complicated. but it's doable. Just looks different. So there, like, forget about this stuff for the moment. Just focus in on this right here.
Okay.
So you're taking in words here. We're gonna somehow get a derivative, and then we're gonna evaluate, just like the previous problem. Okay, so now when you look at x times f of x, and your options for rules are power rule, product, and quotient, which one do you think applies here?
Product.
Yes, it is a product. It's not the kind of product you're expecting to see though, because it's a product of x and a function.
Right.
But you just apply the same, you treat this as u and this as v. So your derivative of this is u v prime plus v u prime. And so if you treat u as x, it's x, v is f of x, so f prime is f prime of x. So you take your u is really x, your f of x is really v, u v prime means keep the x, and then v becomes f prime of x, for v prime is f prime of x, plus v, which is f of x, and then u prime, well, the derivative of u is 1.
Okay.
Excuse me. Okay, so now we'll go back and we'll actually grab all this original mess. Okay, so they want the derivative at x equals 2. So this is where you take the 2 and you plug it in wherever you see an x.
All right.
So it's 2 times f prime of 2 plus f of 2 times 1.
Oh, and then you use the numbers that they give you. I remember doing this.
Yes, yes. It looks worse than it actually is, but it can be overwhelming because you might think, I don't know how to take a derivative of x. What is f of x? They sometimes do this with a table rather than
right. That's how my teacher in high school would do it. I remember.
Yes. So you got 1/2 plus 3. Can't leave it like that. You have to match these up. So it's 7/2.
Okay.
Any questions on that?
No.
Okay. So we're going to do one. My screen is frozen. Okay. We're going to do one like this, except we're just going to make a small change here. We're going to go f of x over x. So we use the quotient rule. And let's change this so that it's nice. Let's change it to -1 for the moment. So
all right.
see if you can apply the quotient rule here. I'll work it out here, but I'll let you have a minute or two to get started.
All right. I got -5/4. Sorry, there's an ambulance.
Okay. Well, I had leaf blowers and chainsaws earlier. The neighbors were doing
I can never find a quiet space.
Yeah, so that's one of the ways that, you go to college, you're like, where do I go to study? And there's library and there's your dorm room, or, sometimes they have
Yeah.
common rooms, but it's like, it's not quiet. Not like, oh, just go home and close the door.
Yeah, exactly. Is that right? -5
Yeah, I just need 30 seconds here to do something, but we can keep going here. Let me
Really?
just give me just. All right. Out of the problems we did today, which one do you think you'd like one more of for us to look at, or two?
Maybe 7C. I messed that one up a little earlier.
Talking about the one with like let's say it's I don't know,
C,
TQ
this
C
one, not
C.
B.
Okay.
Yeah,
Okay.
sorry.
C1. Got it. All right. 7C. So let's go the fifth root of x squared minus 1 over the square root of x. Just keep it kind of simple there. Do you want to see me work through it, or do you want to try it on your own?
I'll try it
Okay.
first and then. Okay. Does it become -1/2 because you are like moving it from the bottom? Yeah. Okay.
Yes. Yes. Becomes negative. Good.
Doesn't the 1/2 need to have like to the -3/2?
Yes. Yes.
Yeah.
I got distracted there.
And then that you just leave it like that.
Yes.
Okay. Cool.
So I guess we've got another session tomorrow.
I think so. Yeah.
So we can do more problems or not. But is that? I think
Yeah.
that's
Probably
everything.
just more problems tomorrow, I think. Yeah.
If you can get your hands on any other practice materials, maybe shoot your instructor an email and see if they can supply anything. But yeah, we'll just keep going
I
then.
can send you some of the problems from our notes too, maybe.
Good. Yeah, and I can make some more like that for you to work on for tomorrow.
Okay. Awesome.
All right. Thanks. Hope you have a great rest of your day.
Thank you.
Okay, bye now.
You too. Bye-bye.